Now that we know what GDP is and how to calculate it, we're going to learn about real GDP and nominal GDP, what they both mean, what they're each good for, and how we use them in measuring the economy. You learned the big equation on Module 10 for GDP, SIG XM, consumer spending plus investment spending plus government spending plus exports minus imports equals GDP. But there's going to be another way to figure out GDP when we have individual outputs. So we're going to use this when you're given a list of multiple products. For this equation, you're going to do the price of the output, P, times the quantity of the output, Q. And we're going to use these numbers to compare how GDP this year is different than GDP last year. Did our economy produce more? How do we know? So if your economy is P times Q, price times quantity, what would happen if prices rise? Then this part of the equation would increase. And if this number goes up, GDP is going to go up. But that's deceiving. GDP is supposed to measure how much we produced, gross domestic production. But just because prices went up, did our economy actually grow? No, it's just gotten more expensive. That could be that our country is experiencing inflation. And that has nothing to do with showing growth. That would not be what we're looking for. So what we want to happen is the quantity to increase. We are making more stuff, and that's why our GDP is increasing. Well, with this simple, unadjusted GDP, it's impossible to tell what increased. Did prices increase or quantity? That's going to lead us to different types of GDP. GDP, if it's measured by price times quantity of the output, could rise for two reasons. Maybe GDP increased because we have economic growth. That's the best possible situation. But if it rose because of growth, which number increased? Was it the price or the quantity? Quantity. If the price is the part that went up, then maybe it looks like our GDP is bigger, but really we're just experiencing inflation. So we need to know how to tell which factor increased and made it look like our GDP is bigger than it was. So the big solution to our problem of not being able to tell did prices go up or did quantity go up is real GDP. So real GDP is using the GDP factors, but we're going to adjust for price changes. So we're going to actually have to do calculations to figure out, did the quantity increase or do we just have inflation? This is going to be a different equation, and it's going to tell us, do we actually have growth? And this is going to show us really if our economy is bigger, then our aggregate output would have gone up. Remember, aggregate means total or overall. So the aggregate output is the total quantity of all the final goods and services produced within our country in a year. We want the aggregate output to go up, not the price level. And we'll only know that using real GDP. Here you have a table showing two goods and two different years. So we have year one and year two. The dates don't actually matter. We can tell that this is a date in the past and then a later date. So apples. From year one to year two, the quantity of the apples went up, but the price of the apples went up as well. The other good we're looking at, oranges, the quantity of oranges produced went up in year two, but the price of oranges went up also. So knowing that the quantity of both goods rose, we know that our economy did grow. So our GDP should show growth. But the problem is when price and quantity are both growing, how do we know how much the GDP actually increased? Is it 3% better? Is it 70% better? How do we know? So in order to figure out the percent increase in GDP, we're going to use this equation. This is going to be a wonderful generic equation that you're going to use in other sections too. This is the percent change equation, and we can use this here to figure out the percent that GDP changed from one year to the next. But you could also use this if it was inflation rates. How much did inflation change from one year to the next? So anytime you need percent change, you're going to use this equation. This is cross multiplication. So we have x over 100 equals year 2 minus year 1 divided by year 1. Now, what if it didn't say year 2 and year 1? That's okay. It could be 2020 minus 2010 divided by 2010. You're still doing the same thing, aren't you? It is, a year in the future, or a later year, minus the original year over the original year. Sometimes this is thought of as change over original, but I wanted to make sure that you set it up this way because occasionally there'll be a negative number. It is possible to have a negative change if your situation you're looking at shrunk. In this case, we know we should get a positive number because we can tell GDP did grow, our quantity's higher. We just need to figure out how much. Now you know the equation for calculating the percent change. So go ahead and use the numbers from this table, plug them into the equation, and figure out what is the actual percent increase in GDP from year 1 to year 2. Take a moment, pause this, fill in the numbers, see what you get. Okay, so I'm going to reveal the answer. Okay, the answer is 50%. It's a 50% increase, and I'm going to show how I got that. So, x over 100 equals year 2 minus year 1 over year 1. So, year 2 for GDP is 1,500, year 1 is 1,000 divided by 1,000. Now, that might still look like too much to you. Okay, so we'll simplify it further. 1,500 minus 1,000 equals 500. 500 divided by 1,000, you can start crossing out your zeros. So we cross out a 0 from each, cross out a 0 from each. Okay, so now we have half. 5 divided by 10 times 100 when you cross multiply. That's much easier. Or you might be able to look at 5 out of 10 and know, oh, okay, that's 50%, even without having to do the cross multiplication. So however many steps it takes, the GDP increased 50%. Now, the next question is, did the real GDP increase 50%, or did just the unadjusted GDP go up that much? Let's find out on the next slide. Now let's practice using the percent change equation again and figure out the percent change in real GDP. So take a moment, plug in the numbers that you have for real GDP from the table, and let's see what that percent change was. Okay, hopefully you paused, and I'm going to reveal the answer. So the answer is 15%. And here's how I got it. So I have x over 100 equals year 2 for real GDP is 1,150. So I have that number here minus year 1. This is the same year 1 for both. This you can simplify down to 150 over 1,000. Again, might be a bit much, so let's cross out some zeros. Now 15 out of 100, that's 15%. I know from looking at it, but you can also, of course, cross multiply to get it. So the percent change in real GDP is 15%. So you have two numbers now. GDP increased 50%, real GDP increased 15%. So, did the economy grow? Yes. But if you were asked how much, you always want to give the answer of whatever real GDP said. The economy grew 15%. That 50% growth also shows a price increase. And that isn't actually telling us how much the economy truly or really grew. So the real GDP gives the real answer when it comes to how much we really grew. So knowing that real GDP is the measure of GDP that shows us how much the economy really grew, we're going to use a different equation to calculate this one. You might have noticed that the old GDP equation was price times quantity. Now we have a different situation. We're going to have to look at prices in terms of what if prices didn't change. In the apples and oranges examples, prices went up. But if we're going to see how much the economy really grew, we have to look at old prices and try to adjust away to not see the effect of prices too. So here we have the base year price. The base year can be any year. It's usually a year in the past. And we look at that to see, okay, compared to 2005, pick a year. Let's see how much the economy grew. So we're going to look at the current year's output. That could be any year at all, but base year prices. So real GDP is different from the other GDP equation because that one you're looking at year A, price times quantity. But this one, it's base year price times year A's quantity. This is going to show us growth, and we use this to measure growth between nations because it's a lot more accurate, especially if one country is experiencing inflation and the other one's not. Real GDP is when we have to adjust the GDP information in order to only see what happened to quantity. So nominal GDP is the GDP at current prices, not base year prices, not looking back to see how they've changed. So the nominal GDP is the non-adjusted one. So the little subliminal trick here, the mnemonic device, is when you see nominal, think non-adjusted. There's lots of different nominal things. Once you learn about nominal and real, we're going to use those words for nominal and real wages. Your nominal wage is just how much you get paid, not adjusted. Your real wage is we're going to adjust it to see how much inflation affects how much you get paid. There's nominal and real interest rates. So these terms are going to be used a lot in econ. Nominal is always the raw number, the unadjusted number. There might be inflation, we don't know, as part of that one. Real, we're going to factor out the effect of the price change. We're going to remove the effect of inflation for real. So because nominal is the raw number, it's also the default one. So if you just see GDP and it doesn't say nominal or real, it's nominal. So always assume that as a default. In this picture, we can see an economy where the same economy, the real GDP is kind of this low, stable blue line. The nominal GDP in gold is going way up. So what does that tell you? If the real GDP is stable, but the nominal GDP is rising, what's happening in that country? Hint, is the economy growing? No, real GDP is stable. So what's happening if the nominal GDP by itself is going up? There's got to be inflation, because we would remove the effect of inflation in real GDP, but since nominal is price times quantity, you could have a huge rise in price that would make nominal GDP go up, but it's not the actual thing, it's not the real GDP that's happening. Now let's practice this concept of real and nominal GDPs and base years versus current years. So suppose you want to adjust nominal GDP in 2009 to real GDP. And we want to compare that to 2008. 2008 will be our base year. So what year's prices would you use? Would you use 2008 or 2009 if we're converting it to real? Real, we're always looking at the base year prices, and 2008 is the base year because we want to remove any new changes in prices and look at an older time to see what's happened. So for real GDP in 2009, we're going to have base year prices, but what year's output levels are we going to use? 2009, because that's the current year we're measuring. So for real GDP 2009, base year prices 2008, current year's output 2009. Look at this table and determine which of the 3 years economists are choosing to use as the base year. The answer is there. Find it. Okay, what's the answer? It's 2005. And if you couldn't find it, the clue is here in this heading. It says real GDP in billions of $2005. So that means that they are using 2005 as the base year. You can use any year you want. Usually, it's a year in the past that we choose to be the base year, but it could be really any year, as long as that year's already happened and we have information. You could use 2009 to look back at 2001. We do different things for different reasons. Now, how this works, you can see that the nominal GDP is rising, right? So it looks like our economy is growing. When we do the real GDP, there is also growth between those years, but the real GDP of 2001 is higher than the nominal one. Now that usually doesn't happen because, nominal is price times quantity, real is quantity times a base year's price. So if we're removing the effect of price increases and quantity is the same, the only way that could happen is if the base year price you're looking at was higher than the year you're measuring. So not something that you have to 100% understand, just putting that out there in case you're concerned about why that happened. And then also, just so you know, that we're doing macro 101 type stuff. Economists out in the field often chain link real GDP, which means instead of just using one base year, they'll link a couple of years together because they want to see a trend. Otherwise, how would they know which specific year to pick? They chain link quite a few together, and that way we can see trends in real GDPs across countries. Let's go ahead and practice how to calculate nominal GDP and real GDP. If you'd like, go ahead and pause and solve this right now on your own. If not, we can go ahead and do 2007 together, and then you can pause and do 2008 on your own. So really, whatever your level of comfort is. So first of all, for nominal GDP, our equation is current year price times current year output. So if we're doing pumpkins, the tons of pumpkins, that's telling you the quantity. Now, if you're not sure how to do 100 times 100 without a calculator, you just count the zeros. So let me get a pen. Here we do it. So 100 times 100. 1 times 1 is 1. And how many zeros do we have left? 1, 2, 3, 4. 10,000. We're going to add that to soybeans. So the quantity of soybeans, I'll just put Q here so we're totally clear. Okay, the quantity of soybeans is 80. The price is 50. Now, this is another one of those where people get in trouble if they don't count the zeros. If you think the answer is 400, it's not. This is why. 8 times 5 is 40. Then how many zeros do we have left? 1, 2. All right, so 10,000 plus 4,000 equals 14,000. That's where the nominal GDP information comes from. Okay, if that made sense to you, go ahead and do 2008 on your own. Try not to use a calculator. Come back to me and we can check the answers. Okay, 110 times 110 equals 12,100. It's very hard writing with this cursor mouse. Sorry about that. And then we're going to add that to 80 times 100. Count your zeros. We have 8 times 1 is 8. And then we have 3 zeros left. Okay, so 12,100 plus 8,000 equals 20,100. You don't have to show all of your work in this nominal GDP box. This is just where the answer goes. Okay, for real GDP, I'm going to go ahead and change colors of the pen just so that we can keep this straight. For real GDP, first of all, we need to know the base year. The base year is 2007. And our equation for real GDP is that it's the current year's output. So all of these, but the base year price. So only the 2007 prices. Let's see how that works. So for 2007 real GDP, current year's output times base price. Oh, we've already done that one. That's 10,000. Then current year's output times base price. Again, we've already done that one. Point of the story is that if the year you're doing is the base year, the number should match. Doesn't that make sense? If you're doing current year price or base year's price, but it is the base year, that's the exact same thing. So save yourself the trouble next time and don't make yourself do the work if it is the base year. Those should always match. But 2008 is going to be different. So for this one, we're going to look at the current year's quantity. Sorry, I kind of messed that one up there. Here we go. Current year's quantity times the base price. So 110 times 100. We don't look at this price. This price is not important to us for real GDP. For soybeans, we're going to look at the current year's output times the base year's price. We've done 80 times 50 before. It's 4,000. Boy, that's messy. I'm sorry about that. 11,000 plus 4,000 equals 15,000. All right, so that's how you do the math. Now, the question is, did the economy grow from 2007 to 2008? Yes. How do you know? What are we looking at? Are we looking at the nominal GDP or the real GDP? Real GDP. And it is bigger, but it went up by less than we think. The real GDP did increase 7.1%. The way I got that is I did that x over 100 equals year 2 minus year 1 over year 1. In this case, 2008 is going to be year 2, 2007 is going to be year 1. So the economy really did grow, but it grew 7.1%. It did not grow 43.6%, as you would think if you were just looking at these two numbers. Now that we've done this once, let's practice it again. Go ahead and do this math without a calculator. Pause the video, come back, and check your work. Okay, let's go through how we do it. So, there's widgets, gizmos, and thingamajigs. For nominal GDP, we're just looking at 1 year at a time. So 100 times 1 is 100. 10 times 8 is 80. 5 times 4 is 20. You add the three of those together, and we get 200. So all you have to put is the answer. I'm showing my work where I got that number from. But in terms of if I just asked you what's the nominal GDP for 2006, if you tell me 200 and it has to be $200, that's very important. GDP is the value of goods and services. If you just put 200 without a dollar sign, you're going to get some points off there. Okay, now the nominal GDP for 2007. 101 times 10 is 101. 11 times 10 equals 101. 4 times 5 is 20. And of course, all of these numbers in my work, they're all dollars too, but just leaving it be. So 110 plus 110 plus 20 equals 240. Dollars, of course. Now, for the percent change in nominal GDP, before I reveal the right answer, let's practice how we do this. I'm just making some room here. Okay, so percent change, our equation, x over 100 equals year 2. So in this case, year 2 is going to be 2007 because that came later than 2006. So 240. I'm going to do the dollar sign here once, so it's still part of our equation. Okay, 240 minus year 1, which is 200, over year 1. Okay, that leaves us with 40 over 200. We can cross out some zeros. 4 goes into 20. That's 1/5. When you cross multiply, 1/5 equals 20%. I know I'm doing work the long way by not using a calculator, but because you can't use a calculator on the AP exam, we're practicing doing it that way now. So the percent change, 20%. This is possible to be a negative number, but because it's a positive number, we know that that means that the economy grew. So let's do some more practice with base years and real GDP. So in this case, we're going to use 2006 as the base year, and we're calculating the real GDP for 2007. So which year's prices are we going to use? 2006, because they're the base year. So I'm going to go ahead and circle, we're going to use the 2006 prices. This helps sometimes. And what year's quantities are we going to use? 2007, because that's the year we're studying. That's the year we're focusing on to get their real GDP. Okay, now you're just multiplying the two of these things together. So 100 times 1 equals 100. 10 times 10 equals 100. And 5 times 5 equals 25. So you add those together, 100 plus 100 plus 25 equals 225. That's our real GDP for 2007. Now, if we wanted to see how much the real GDP changed, we're still going to use our same x over 100 equals year 2. Real GDP for 2006 was 200. How do I know that? Well, that was the nominal GDP for 2006. And if it is the base year, the nominal and the real are the exact same number. So That's 2006. Let's see if I can make this fit. 2006. All right, and here we have 2007. So for year 2, minus year 1, divided by year 1, we have 25 divided by 200. All right, that's not as perfect. That's the kind of math that you might need a calculator for. So here we have it. We have the real GDP of 2006 was 200. Real GDP of 2007 was 225. So the percent change, once you cross multiply with those numbers, is 12.5%. So that is the amount that the economy actually changed from 2006 to 2007. Now that you know all about nominal GDP and real GDP, we're going to focus on GDP per capita. Because we're using these numbers to compare the growth rates between nations, it matters to us if one country has 6 million people and one country has 60,000 people. Clearly, they're not going to be able to produce the same raw number of goods. And it's really unfair to compare productivity of those nations by looking at just those numbers. So we're going to convert those numbers into GDP per capita. Capita is Latin for head. So this is the total number of people in the country. So you can use per capita for real or nominal GDP. All you do is you take the number and you divide it by the number of people who live in that country. That's it. Any value here can be done per capita. Normally, if we're looking at how much an economy grew compared to another country, the most accurate unit of measure is real GDP per capita. If you feel like you've gotten this done, great. If you want one more practice problem, I added one more on the next slide that's not in your notes, just to give you some extra practice. Up to you. Okay, so this one I made up all of the numbers, and they're not going to be pretty. So please do grab a calculator for this practice one. You're still setting it up the same way. I just wanted to show you how it's done. Also, the way that this slide is being filmed, if I erase something, it's going to erase everything. So go ahead and keep track on some scratch paper what you're doing at the bottom. When you find the nominal GDPs, the real GDPs, write them down in your paper because they're probably going to disappear on my screen, to just let you know. Okay, so let's get started. So nominal GDP for 2001. So first of all, pizza. And I'm going to try not to show all the steps. It's going to get really messy if I do. So 8 times 10 equals 80. Plus 3 times 6 is 18. Plus 1 times 2 equals 2. So that's going to be 100. Remember, GDPs are always in dollars because the price is included. All right, nominal GDP of 2002. 9 times 17 equals 153, plus 5 times 8 equals 40, plus 1 times 3 equals 3, so that's going to be 196. Nominal GDP of 2003. 12 times 5 equals 60. 7 times 10 equals 70. 2 times 6 equals 12. Hold on one second. There we go, 142. I had a mistake in my calculator. Okay, now first of all, I want you to see that the nominal GDPs aren't getting bigger, bigger, bigger. So we're going to actually maybe have some negative numbers coming up, which is good practice here. I'm going to change ink colors a little bit. Let's do some real GDPs. Remember, you could choose any year as the base year. Let's go ahead and do 2001 as the base year, but if you wanted to set the base year as 2002, you certainly could, and that's going to change all your real GDPs and your percent changes. So set it to whatever you want. Now, if 2001 is our base year, do I have to do any math to figure out to convert the nominal GDP to the real GDP? No, because it is the exact same number when it's nominal times real. Okay, just to keep things simple here, for real GDP 2002, remember it's the base year price. And then the year we're looking at is quantities. So in this case, it would be 8 times 17 equals 136 plus 3 times 8 is 24 plus 1 times 3 is 3. And then for 2003, we're going to look at the 2003 quantities, base year price. 8 times 5 is 40, plus 3 times 10 is 30, plus 1 times 6 is 1. Okay, how'd that go so far? All right. So remember, for the percent changes, it's always x over 100 equals year 2 over year 1 divided by year 1. Sorry, year 2 minus year 1 over year 1. And here, the way these are set up, you can tell that the earlier year in the question is year 1 and the later year is year 2. So for this one, it's going to be x over 100 for all of them, but real GDP 2002, 163 minus 100 divided by 100 equals x over 100, of course. That's going to simplify to 63 divided by 100, which is 63% when you cross multiply it. So that is a positive number. So we know that the economy grew from 2001 to 2002, 63%. Now, the percent change from 2002 to 2003, now we have year 2 is 2003, so 76 minus 2002, so 163. And it's going to be divided by 163 because that is functioning as our year 1. It's the earlier year that we're looking at. Now that's definitely harder math. 76 minus 163 equals negative 87 divided by 163 times 100. So the answer here is negative 53. I'll just do 1 decimal point, 53.4%. You might say, why is it negative? Well, that's showing that there was negative growth, which is true. See how the real GDPs got smaller? So if you had a positive number here, then we have a problem because the economy did shrink. So there was negative growth, negative 53.4% to be precise. So hopefully this was extra practice with 3 goods, 3 years, negative growth, some not very clean numbers, all that jazz. If I ever ask you to do math like this one on a quiz or on a test, I would say use your calculator because it's not going to come out clean. Anything that you do without a calculator should be stuff that you should be able to do with paper. Now that you know the difference between nominal and real rates, I wanted you to see that there's actually going to be many, many uses of nominal and real in macroeconomics. So we have nominal and real wealth. That's the idea that one person might have $1 million. But if someone else had $1 million in a place that had a lower cost of living and maybe lower inflation, that $1 million, that wealth would go further. So the person with $1 million where inflation was lower would have more real wealth. Income is similar. You might get a raise, but if you get a 5% raise and there's 8% inflation, did your real income go up? That's the same as real wages. So the idea is hourly or over the course of a year, if your income or your wages are going up at a higher rate than inflation, your real wage, your real income rose. If income and wages are going up slower than inflation, your real income or real wage fell. We already know about GDP. Money supply. So if the Federal Reserve prints more money, the nominal money supply increased. But if that money doesn't go as far because the inflation means the purchasing power of money is down, that money won't buy as much, then the real money supply has decreased. You're going to learn about interest rates later on this unit. Interest rates are a little bit different. So here's the issue. The first five, and a simple way to convert between nominal and real is if you divide the price index, which is the amount of inflation, from the nominal value, it'll give you the real value. So that is one way to adjust for the first five. Interest rates are the only one that are a percentage. So because they are a percentage, they have a different way of calculating. Nominal interest rates minus the price level or minus inflation will give you the real interest rates. And again, we're going to see that equation again this unit. We're going to see the concept of nominal and real interest rates much more detail later this unit. But I want you to see that nominal and real isn't just about GDP. There's lots of things in the economy that have a different value if we have inflation than if we don't. So anytime you see nominal, that's always the not adjusted number. And anytime you see real, that means it's been adjusted for inflation. So no matter what the thing is, nominal is not adjusted, real is adjusted for a change in price level or adjusted for inflation.